sampling distribution of mean and sampling distribution of proportion. Today our discussion is about confidence interval estimation. The confidence interval estimation is based on the concept of sampling distribution. Now these are the learning objective of this chapter. Construct and interpret confidence interval for mean and proportion. Then how to determine the sample size necessary to develop a confidence interval for mean and proportion. Then read the detailed chapter outline. The confidence interval for population mean we can calculate using under two scenarios. The first one is population standard deviation is known. The other one is it is unknown. And also we will learn confidence interval for population proportion and learn how to determine the sample size. Okay, then we have two concepts called point estimate and interval estimate. Then I can explain the concept of point estimate and confidence interval using a simple example. Let's say now in this class Zoom meeting, we have, including myself, we have 32 individuals. Let's consider this as our population. It is a 32, but let's assume it is something like 32,000. Okay. It's a big, we know the population is a big one. We consider, now we have 33. Let's say these 33 students we consider as a population. Okay. Now let's say we want to do a study about this population. We want to do a study about this population. The standard method or scientific method is select a sample from this population. Select a sample from this population. Because if you going to collect information from this population, it takes time and may be difficult to analyze the large data set. Now let's say we select 10 individuals or 10 students randomly as a sample. Okay, we select 10 students as a sample. Normally, simple N stand for sample. Capital N stand for population size. Simple N stand for sample size. Then to select the 10 individual, we can use, let's say, simple random method. As we discussed, you can use either computer random seed to select these 10 students. Then actually now for this work or this activity, the 10 student can voluntarily reply the question. Okay, I'm not going to select, but the 10 student have to reply for the question. Then based on their answers, I explain the concept of point estimate and confidence interval. Now we have select a 10 student. Then we can get some data or information related to, let's say, very simple example, number of let's say WhatsApp message you received, let's say last 1 hour. Okay. Now let's say 12, let's say 12 to 12 to 4, 12 to 5. Okay. Our study is about number of WhatsApp message you are receiving. Okay. And then the 10 student, I'm not going to nominate or I'm not going to select. 10 student, any volunteers, now they can check their phone and count how many WhatsApp message you have received last 3 hours time, no, 5 hours time, 12 to 5. Then your information you can send into chat box, or else I can share quickly Google Sheet. Then you can enter your information into Google Sheet. Did you got the point? I don't need from all. I need from 10 students. Okay, I send the link for Google Sheet. Please enter your information into Google Sheet. Yes, one has entered. Hello. Yes. Now I have received, I think, yes, 8 answers. Then 2 more. Can you reply? Hello. I need 2 more answers. Oh, we can. Yes. One more. One more. Oh, don't delete some numbers. I think one has. Okay, then I think now we have 10 observations. Okay, 10 observation. Then don't change again. Okay, please. Okay, then our study is about number of WhatsApp message. Now the size is sample size is 10. In the population, we have 34, 34 individuals. Okay. Then you can see the numbers. The minimum is 2. Then the maximum is, what is the maximum? 275. Okay. These are the max. Minimum number is 2, maximum is 275. Then now we can calculate average value. First, if you want, you can get the sum. Sum mean summation of these values. Okay. It is 958. Then the average value we divide. We can get the average. Average value is 95.8. Okay. This is the sample average. We call X bar. It is 95.8. Okay. That means on average, during last 5 hours, the student have received 95 WhatsApp message. Now these information are based on our sample. It is only a one single number. It is only a one single number. It is we call point estimate. This value is applicable only for your sample. You can say in your sample, the average number of WhatsApp message is 95.8 for 5 hours time. It's a huge number, no? But the minimum is 2, maximum is 275. Then actually our objective is not to make a conclusion related to population. We want to make a conclusion related to our population. Let's say population is a large group. In this example, it is 34. And if we need, we can get the information from these 34. But let's say It's a very big number. Then practically we can't get the data from this population. Now, based on this sample data, you want to make a conclusion about population mean. This is the symbol for population mean. Okay. The sample mean is 95.8. Then what you can say about population mean based on the sample survey data? What is your conclusion about the number of message received this 34 student, our population? Who can make a conclusion about this population mean? Any comments? Any idea? Similar, yes. Then his idea is now we randomly select the sample. Randomly mean it's you reply. Okay, it's also something like random selection. If we select if our sample is random sample, we can assume the sample represent our population. Then his argument is then the population mean also 95.8. Okay, his argument is this sample is represent the population, then he can make a conclusion about population mean also equal to 95.8. How about others' ideas? Do you agree? Others? Any other comment or any idea? Yes, please.
So unless we know that the sample is a representation of the population, we can't say anything. No?
Your argument is, let's assume sample is random selection and the sample represent population. Then if it is random and represented the population, do you agree that population mean also equal to 95.8? Yes.
Could be similar. No?
Would be similar. Okay.
Close to that.
Okay, any other idea? So, actually now in this case, actually our population is 34. The sample is nearly 1/3. Then it is actually quite good representative sample. Yes, any other comment? My simple question is, if now as you conclude, if I say that sample mean is 95.8, population mean also 95.8. Do you agree with my statement? It's make you, but I again repeat it. If I say that sample mean is 95.8, the sample is a representative sample and the sample size is 1/3 from the population, then you can say in this population, average number of message received last 5 hours is 95.8. Do you agree? Okay, then this is my statement one. As you conclude, this is the statement one. Then another statement I can make. I can say I am 95% sure, or I am 95% confident the average number of message received in this population is between 90 to 100. My statement is I am 95% confident the population mean is between 90 to 100. Then there are two statements. One say that sample mean is 95 point, sample is representative sample and sample size is large. Then the population mean equal to 95.8. This is the statement one. Then the second statement I say that sample mean is 95.8. Then I am 95% confident the population mean is between 90 to 100. Which one is correct? Which one? Now there are two statements I have. Which statement are you accept? Second one. Yes. What is the reason? Uh, yes. Yes. Any other idea? That is that's correct. Yes. Any other idea? No. Then you can see I made the statement saying that I am 95% confident. I'm not going to say I am 100% confident. My statement is I am 95% confident the population mean is between 90 and 100. But here statement is population mean equal to 95.8. This is completely wrong. It won't be. You can't say sample mean is 95.8. You can't say population mean is equal to 95.8. This is completely wrong. It might happen, but uh, there's a 99% sure that it will not happen. Because population is a large group. In the sample mean, now when we discuss sampling distribution, you realize that this is the sample mean. Okay, you realize that most of the sample means are around the population mean. Okay, now this is the population mean. Then the sample mean is around the population mean, but it is not similar. Then this is we call confidence interval. Confidence interval. Then why actually we make confidence interval? Why we make confidence interval? We want to make a conclusion related to population based on our sample survey data. Okay, because the objective of the research is not to make a statement only for the sample. You select a sample to make a conclusion related to population. Then if you want to make a conclusion related to population, then definitely you have to use confidence interval estimation. Without confidence interval estimation or hypothesis testing, you can't make any conclusion related to your population. Now, I think this is maybe you got the idea. In the stat, actually, the calculations are not very difficult because you can use a computer software. Then once you give the command, they will give the results. But key point is you should have a clear idea about the concept and the technique. If you are clear about the technique, then you can apply. Now this is we call uh, interval estimation. This is we call point estimation. Okay. Then if you don't mind, actually now I collect data from 10 students. Okay. If others also willing, they also can enter their information. Maybe I can copy this one and let's say paste. Then we can see whether our statement is correct or wrong. Okay. If you can, now there are 32 students. While we are doing lecture, if you can, others also can enter their information into this column. Okay. Then at the end, we can see how confidence interval work, whether it is correct or whether it is uh, what what extent it is a correct statement. Okay, it is my request. It is better if you can. Others also can enter their information into this sheet. Okay, while we are doing the lecture. Then now two concepts are now clear to you. Okay, the two concepts are point estimate and interval estimate. Okay, the point estimate is a single number. Point estimate is a single number. It is actually based on sample. It is people sample mean. Then the confidence interval provide additional information about the variability of the estimate. Okay. Then the lower confidence limit and upper confidence limit. In my example, I just get the 90 and 100. Okay. This is we call lower confidence limit. This is we call upper confidence limit. Then my statement is I am 95% confidence the population mean is between 90 to 100. Why I say like this? Because the sample mean is 95. It is based on a sample. If I select another sample, let's say now 10 students reply for this. Let's say I select another 10 students. Then do you think that their sample mean also equal to 95? No, it may be something different. Sometimes it may be 85. It may be 75. I don't know. Okay. Then when we consider or when we calculate confidence interval, we consider variability of the estimate. That is the variability of estimate. The variability of the estimate means if you select another sample, the sample mean is not 95.8. It means something else. Then when you calculate confidence interval, we consider variability of sample estimate. Then it is we call confidence interval. Then we can construct confidence interval for population mean as well as population proportion. Okay, then the same thing here, I think. The confidence interval, how much uncertainties associate with the point estimate of a population parameter. That means now as I explained, the sample mean may change from sample to sample. Then the interval estimate provide more information about population characteristic than does the point estimate. And such interval estimate are called confidence interval. Same thing here again. Take into consideration variation in sample statistics from sample to sample. That means our sample it is 95.8. If you select another sample, sometimes it is maybe 85. When you construct confidence interval, you have to consider these variation. It is based on the observation from a one sample. Give information about closeness to unknown population parameter. Stated in terms of level of confidence, 95% no, 99%. Never 100%. That means you can't say, I am 100% sure the population mean is between 95 and 90 and 95. You can't say I'm 100% sure. You can say I'm 99% sure or 95%. Okay. This is the main concept of confidence interval. Is it clear? Then you think that, can you answer this question if I ask a question from you? Why we estimate confidence interval? What is the answer for this? Why we estimate confidence interval? Or what is the importance of estimating confidence interval? Please give some idea. So my question is, now I explain the concept of confidence interval and I highlight the important also. Then I want to check whether you got the point. The question is why we estimate confidence interval. What is the importance of it? Any answer? One say determine the confidence of sample. Actually, why we construct confidence interval? Yes, please. Uh, Not the point estimate, the population mean, no? Yes. Yes. Actually, the direct answer is why we estimate confidence interval. The very short and direct answer is to make a conclusion related to population based on sample survey data. That is the key point. We want to make a conclusion about population mean based on sample mean. To make a conclusion about population mean based on sample mean, you have to estimate confidence interval. Your answer also correct, then that is the key point. Okay, did you got the point? Not the now these answers are not correct. One say that the accuracy of sampling determine confidence of sample. No, these are not correct. The main reason for estimating confidence interval is to make a conclusion about population mean based on sample mean. Without confidence interval or hypothesis testing, you can't make a conclusion related to population. The sample mean is 95, but you can't say population mean also 90. It is wrong. Then if you want to make a conclusion, you have to construct confidence interval. Then the estimating confidence interval is a very simple task. With the Excel or maybe SPSS or maybe Stata, you can get the direct answer. But you should be clear about the interpretation, why we use confidence. The main reason is to make a conclusion about population. Then the confidence level is the confidence interval will contain unknown population parameter. The confidence level is always less than 100. We are not going to say 100%. Now I'm going to explain how to calculate this upper limit and lower limit. Okay. Now let's say another example you can see here. The sample mean is 50. Sample mean is 50. Then I can say I am 95% confidence the population mean is between 40 and 60. Population mean is between 40 and 60. It is the confidence interval. Now I am going to explain how we can estimate these lower limit and upper limit. Actually, this is the very simple formula to estimate confidence interval. Then we have point estimate. Point estimate mean sample mean plus or minus the critical value. It is from table according to our confidence level. According to our confidence level, the critical value we can get from T table or Z table. Later I will explain how to get the critical value. Then the standard error, we learn this concept, standard error of the mean. Okay. Then to estimate the confidence interval, you should know only three values. Sample mean, it's very simple. Then the standard error of the mean, actually we learn this one, standard error of the mean is equal to population mean, population standard deviation divided by square root of it. If the population standard deviation is known. If it is unknown, standard error is equal sample standard deviation divided by square root of it. Then here T, the critical value. To get the critical value, you have T table and the Z table. Actually, it is depend on whether you are using T or Z is based on whether you know population standard deviation. If you know the population standard deviation, then the standard error of the mean is equal to this formula. Then if you know this value, then to get the critical value, you can use Z table. If you don't know population standard deviation, then you have to use sample standard deviation. Then you have to use the T table. Okay, then this one I skip. Then as I explained here, there are two methods. Okay, two methods are known population standard deviation and unknown population standard deviation. Then first we will move to known population standard deviation. Then this is the formula you have to use to construct confidence interval. The assumptions are population standard deviation is known, population is normally distributed, population is not normal, we can use large sample. Okay. Then the X bar is sample mean. This is population standard deviation, sample size. Then the Z stand for Z table. Then the alpha stand for level of significance. If you construct confidence interval at 95%, then the level of significance is 5%. Then alpha is equal to 0.05. Alpha is equal 0.05. Then from the table, we can find the value. Is it clear up to this point? If you have any doubt, you can raise.
So can you explain this part again, please?
Which part?
The equation.
This one. Okay, give me 1 minute. Okay, then now this is the formula you can use to construct confidence interval. Now in our example, okay, I make a statement, the population mean is between 90 and 100. Okay, that means average number of message received in this population for last 5 hours is between 90 to 100. This is the confidence interval. It is level is 95%. 95%. Okay. Then actually this statement just I make no. Then we only I had the number sample mean is 95.8. Sample mean. It is from sample. Then in this formula, the sample mean is 95.8 type. 95.8. Okay. Then you can see plus or minus. That means this value plus or plus. Plus mean if you add this part into this value, you can get the upper limit. If you subtract the value of this part, from the mean, you can get the lower limit. Okay. Then what are these other symbols? Then this is actually population standard deviation. This is population standard deviation. That one we discussed earlier. This is sample size. Then if we have entered data into our Google Sheet, we can now estimate population standard deviation and we can construct the confidence interval. Then you can realize it. If you have not entered, then please enter at least if 30 observation or if the 30 are 34 student, then if the at least 30 enter, then we can consider it as a population and we can do the example. Then this part, okay, Z stand for Z table. Z table mean when you discuss normal distribution, I gave a table to you. I think it should be with you. No? Then we calculate probability based on Z table. Z stand for this. Then the alpha stand for level of significance. It is something like this. Okay. Now, in the Z distribution, we know the area under this curve is equal to 1, or you can say 100%. No? Area under this curve is 1 or 100%. Then in the sampling distribution, this is X bar. Then this point, you can remember this is we call mean of the mean. Mean of the mean. Okay. Or this is the population mean. Now what we are going to do is, we are going to identify a range for population mean. Population mean is here. Then we want to find lower limit and upper limit. Okay. Then what is your confidence level? 95%. You can decide. If you want, you can do 95%, 90%, 99%, 80%. The standard or acceptable levels are 95 or 99 or 90. Then now in the sampling distribution, mean is here. Then you want to make a confidence interval, that means the lower limit and upper limit at 95% confidence level. Then that means 95% of sample means are within this range. If you use the 95% confidence level, it says that you are confident that 95%, if you select from 90, if you select 95 sample, if you select 100 samples, no, now from our 34 group, if you want, you can select different samples. 100 samples you can select. Because you can remember we had the population size 4. Then how many samples we select? 16 samples we select. Okay. Then like this, if you select 100 sample, then my statement is I am 95% confident the population mean is between these two values. Okay. Then if this area is 95%, then probability is 0.955. Then how about these two areas? Please think about this probability of these two areas. Hello. Then if this area is 95%, that means in the probability it is 0.955, 9500. Then how about these two areas? What is the probability of these two tails? It should be 5%, no? It should be 5%. 5% mean actually 0.05 divided by 2. Then here alpha is 0.05. If you use 95%, the middle area is 95%. The two tails should be 5%. Then it we divide into two tails. That's why we divide by 2. Then this area, this is the level of significance, 5%. Is it clear? Hello. Yes, you can ask any question, okay? Because I know that most of them have learned stat and most of them have learned confidence interval. Then you may have some doubt. Then you have to clear all these doubt. Yes, any other? Then this is the population mean, or we can say mean of the mean, or population mean. And we are constructing confidence interval, let's say 99%. 99%. Then in this curve, because we make the range, no, this is the lower limit, this is the upper limit. Then this area should be equal to 99%. 99%. If this area is equal to 99%, these two tails should be equal to 1%. 1% means 0.01. Then the level of significance is 0.01. Okay. Then it should be divided by 2. It should divide by 2. Is it clear now? Hello?
Yes, sir.
Okay. Then the same thing you can see here. If this area is 95%, then this is 0.025, 0.025. Then the Z value is 1.96. Then take the Z table and check whether you can identify how we get this value. Yes, do you have a Z table? Okay, later we will move to the Z table. This is from the Z table. I think you can realize this later. Okay. Then these are the normal or acceptable confidence level. If the 95%, it is 1.96, 90%, 1.645, 99.258. These values you can take from the table or just you can remember. These three values you can remember. 99.258, 95%, 1.96, 90%, 1.645. Okay. Then same thing actually here we can explain. It is something like this. Now let's say, as I explained, this is the population mean. Then You can select a sample. Then the sample mean is here. Like in our example, sample mean is 95. Sample mean is here. Now, if you construct confidence interval, this is the lower limit, okay, and this is the upper limit. Now you can see the population mean is within this range. No? This is the sample mean. Based on this sample mean, we identify lower limit and upper limit. Then we can see population mean is within this range. How about in this sample? In the next sample, it is this value. Confidence interval, lower limit, upper limit, then the population mean is here. This one also, this one also. But if the sample mean is like this, then confidence interval lower limit is here, upper limit is here. Okay. Then our confidence interval is wrong because it does not include population mean. It does not include population mean. But what is the probability that we can have a wrong statement? What is the probability that we can have a wrong state? The probability is like this. There is a very small probability we can have a sample with sample mean like this. If you use a proper scientific sampling technique, your sample means are in this range. There is a high probability you have a sample with sample mean near to population mean. There is a very small chance you have a sample with sample mean like this. It is far away from population mean. Then if you construct confidence interval based on this sample mean, then it is your statement is wrong. But to make this type of wrong thing, the probability is very low. That's why that's why we use random sampling method. That's why we use random sample. If you use random sample, definitely your sample mean is around the population mean. Then the confidence interval you estimate based on sample mean is correct. I hope you got the point. These are actually not, you don't want to write down, just you can understand, okay? At the exam, I am not going to ask these things, but you have to understand these things. Is it clear? Okay, then we will move to our example. Now, where it is? Yes. I will download into Excel, okay? Can you see the Excel sheet now?
Yes, sir.
Okay, then this is our sample mean. This is our sample. Then after that, actually, 3, 4, 5. Yes, 21 students have uh, entered the data. Okay, actually we have 33. Now only 22 has entered the data. It's okay. Then now we can consider this as a population. Let's try what will happen. Okay, but if the all are entered, then I think we can have a good results. But here only 21, and I want to check whether this is a correct figure or any typing mistake. 1112. Is it a correct answer or is it a typing mistake? Please. Otherwise, it may distort our picture. Hello? I'm not going to ask who has entered this, but if you don't mind, you can say that it is a correct or it is a typing mistake. It may be correct. I don't know. Yes, please. No. Okay. Then now how to construct confidence interval? The formula is plus or minus Z alpha over 2 population standard deviation divided by square root of n. Then the sample mean we know 95 plus or minus. If the confidence level is 95%, then the level of significance is 5%. Then the alpha value is 0.05. Then what is this value? As I explained earlier. From the table, this value is 1.96 minus and 1.96 plus. Then this value you can take here 1.96 plus or minus. Okay. Then sample size 10. This value we don't know actually. Okay. Then we can consider or we can calculate based on this population. Let's say this is our population. Then we can calculate this. Okay, then the standard deviation is 236. Okay, then okay, then please calculate the answer. Then the 95 plus or minus, what is the answer for this? Please calculate and send your answer into chat box quickly. 1.96 into 236 divided by square root of 10. Please quickly send your answer. Yes, are you doing this one? Please send your answer into chat box. I'll give 2-3 minutes. You can see the answers in chat box. I think they have calculated, I think, uh, lower limit and upper limit. No, it is 241 to 51. 241 to no, yes, minus 51 to is it correct? Then Yes, then now let's see, the square root of 10 is 3.16. Then it divide 236 divided by this value. Okay, 74. Then we have to multiply it by 1.96 into 1.96. Then 146. Yes. Okay. Then the lower limit is 95 minus 146. Yes, your answer is correct. 51 and 241. Okay. Then now our confidence interval is this. Is it clear how we get it? Then I can say I am 95% confidence the population mean is 51 and minus 51 and 241. Now you can see how it's work. Okay. Is it clear how we get this answer? Hello. Okay. Then now what is the issue here? Then if I say that I am 95% sure the population mean is between minus 51 and 241. The one fundamental issue is now our data, this data is actually number of message you receive. Then it won't be a minus 1. Okay. And also if I say like this, between minus value and plus value, in between we have 0 also. Okay. No, minus 51 and let's say 241, in between we have 0. Then I am confident that sometimes it may be even 0. Okay. Then if I make a statement like this, then the population mean is maybe equal to 0. Maybe equal to 0. But it won't be, no? It won't be a 0. But if I use this data and make a conclusion, then my conclusion says that you have not received average may be equal to 0. Why we have received this type of wrong conclusion? These are wrong. Because I am saying that we are 95% sure. No? Then there is a 5% sure that it won't be. Then definitely we know that these are wrong. The wrong mean actually, now if you calculate now this is our population, I think you can realize it, okay? Now when you are doing so many examples, sometimes it may be complicate you, okay? Then what is here? Average is 120. This is the population average. This is the population average. Our sample average is 95. Okay. Then based on confidence interval, we make a conclusion it is minus 51 and 241. Why this is wrong? That's why I asked about this number. Okay. Sometimes it may be correct, but it is an outlier. It is an outlier. Okay. No, then you can see that when this value, if you remove this value, you can see what will happen. Okay. If you remove this value, then earlier we had minus 51 to, what is the value? 241. Okay. The population mean is between these two values. Okay. Minus 51 and this. Then we realize that actually the population mean is 128. 128. But this is a wrong mean. 128 is included here, but the 0 also included. No, minus 51 to 241. Then it is a you can make, but it says that sometimes it may be 0. Okay. Then the reason for these type of conclusion is due to this outlier. Okay, then we can remove this one. If you remove this one, then you can see standard deviation. Standard deviation now, this value. Sample population mean is this one. Okay. Then now again you can construct confidence interval. Plus or minus. Then check what is the value. Then this one does not change. It is 95. Okay. 0.8 plus or minus 1.96. Now sample size is same, 10. Now this value, it has changed to 79. Okay, 79. Now you can check what is the answer. What is the answer now? Yes, please quickly send the answer. What is the lower limit now? What is the lower limit? Yes. Yes. Lower limit is now 95 minus this value. It is around, I think, 50. What is the answer? 46. How it's happened? 46. Square root of 10 is 3.16. Then this is the standard deviation is Sorry, I have made the wrong. I think this is standard deviation is 72, no, not the 79. Standard deviation is 72. Standard deviation is 72. Then 72 divided by this value, then multiplied by 1.96, then it is 50.7. The upper limit 95.8 plus this value. Then it is now 50 to 140. Now you can say I have 95% confidence the population mean is between 50 to 140. Then you can see actually the population mean is 79. It included here. It included here. It included here. Then you can say I'm 95% confident the population mean is between 50 to 140. How you make this statement? Based on your sample. Based on your sample. Then now you can realize your statement is correct. Because population mean is 79. Population mean is 79. Then it's included in your range. Then you can say I'm 95% confidence the population mean is between 50 to 140. Did you got the point? Hello?
Yes, sir.
Okay. Then, now if I ask you to do the same at 99% confidence level, what is the answer? Please quickly do. 99%. If it is 99%, what is the value? Z value? 2.58. Then this value into 2.58 is 59. Then the confidence interval, yes, one has sent 35 to 144. Then 95.8 minus this value. Yes, it is, I think, 36 around. Then this value plus, yes, it is 155. Then you can say I'm 95% confident, 99% confident. The population mean is 36 to 155. Then you can realize again, then when you increase your confidence level, what will happen to the range? If you use 95%, the range is 50 to 140. If you use 99%, your range is 36 to 156. Then you can see with the increase of confidence level, the range of confidence interval will increase. Because now you are saying at 99%. You are saying that 99%, it should be a bigger range. No, you can't say it is 40 to 140 because your statement is at 99%. I hope you got the point. This is the way to construct confidence interval. Okay, then now we construct confidence interval here using this formula. Now you also can remember how to write it. Plus or minus Z alpha over 2 population standard deviation divided by square root of it. Then here the population standard deviation. Actually, when you are doing practical research, we don't know this value. Because if you know this value, definitely you know the population mean also. No? To calculate the now we calculate here it no. Okay. How we calculate? We have a data. Then we calculate population mean also. Then no need to construct confidence interval because we know population mean is 79. Okay. But in the practical situation, we don't have data related to population. If you don't have data related to population, then can you estimate this value? You can't. Did you got the point? Hello?
Yes, sir.
Yes. Then, if you don't know this value, then how can you do? Then we can use Z table. Sorry, T table we can use. Now the same formula plus or minus. Okay, then now T table, alpha over 2. Now sample standard deviation divided by square root of it. Okay. Then if you don't know this value, then you can insert here sample standard deviation. Okay. Then what is the sample standard deviation here? Then you also can calculate. You have data sheet with you. Then the sample standard deviation you can calculate. It is 85. It is 85. Okay, it is 85. Okay. Then now, how to construct confidence interval now? Now we don't know population standard deviation, then we calculate sample standard deviation, it is 85. Then now you can insert here what is the 95. 95 plus or minus T alpha over 2 you don't know. Sample standard deviation. $85. Then you have a doubt how to get this one. I think we did not read, I think, T table. Then this is from T table. Okay, I think I have shared the T table with you. Okay, I have shared the T table with you. Or else, is it clear up to this point? Now, what we did was, we don't know population standard deviation. Then We calculate sample standard deviation, then substitute here. Okay. Then now I am going to explain how we can get this value. Okay. How we can get this value. I think I have shared the T table with you. Then please open it. If you don't have, I can share it again. The table is in the chat box. Can you see the T table?
Yes, sir.
Okay, then I write here again the formula for confidence interval plus or minus T alpha over 2, then the sample standard deviation over square root of 10. Okay. Then these values we know. Then the alpha actually stand for level of significance. It may be 5%. 5%. Because in the table, the middle is 95%. These two areas, 5%. Okay. Then the each tail 0.025. Okay. Then from this table, if you are going to construct confidence interval, you have to consider this two tail 5%, or one tail 2.5%. What is the rationale of this? Because in the confidence interval estimation, if you consider this one tail, it is 0.025. If you consider both tail, it is 5%. Then you take this one, or either this. 95% confidence level mean the values in this range. Then here degrees of freedom. Degrees of freedom mean in this example it is n minus 1. N minus 1. What is the n? N is 10, n minus 1 is 9. Then the 9. Then what is the t value now? 2.62. 2.62. Then your answer is, get the answer quickly, 95.8. Okay. Plus or minus 2.262. Okay. Then this value, I can't remember. What is the standard deviation? I think 85, no? Can you remember standard deviation?
85, sir.
85. Okay. Then quickly get the answer and send the answer into chat box. Yes.
So, what is the meaning of degrees of freedom?
Yes. Degrees of freedom. Actually, now, okay, I think later I can explain it in detail now, but in this example, the sample size is 10. Okay, sample size is 10. Then normally we consider n minus 1 as a degrees of freedom. Okay. Then the meaning is that actually I will give me a 1 minute. Once we finish this one, I will explain it. Okay. Otherwise, it may take some time. Okay. Degrees of freedom I will explain at the end. Okay. Then I think according to these calculations, we can see the lower limit is 35 and upper limit is 156. Then you can say, I am 95% confidence the population mean is between these two values. Is it a correct statement? It is correct. Because actually we observe that population mean is something I think 79, no? Population mean is, what is the population mean? Yes, 79. Population mean is 79. Then our statement is now correct. I can say I am 95% confident the population mean is between 35 and 156. This is the way to construct confidence interval and interpret it. It is very simple. Only the thing is that you should have a clear understanding about why we construct confidence intervals. Then when you are reading T table, okay, you have to consider degrees of freedom and level of significance. Then let's say now we construct confidence interval 95%. Then we use this 5% column. If you want to construct 99%, what is the column you have to use? This one. If you want to use 90%, this one. Then the 90% confidence interval, the p-value this, 95% this, 99% this. Okay. This is the way to read T table. Okay, if you have any doubt about confidence interval estimation, you can raise now. There's another example here, you can do it. Okay. Then this one also I explained the T table one. Then one asks what is the degrees of freedom. Okay. Now this is the concept of degrees of freedom. Number of observations that are free to vary after sample mean has been calculated. Okay. This is the simple definition for degrees of freedom. Freedom means freedom, then degrees of freedom mean the number of observations that are free to vary after sample mean has been calculated. That means without changing sample mean, how many observation can change? Now let's say as example, you have one observation 7, second observation 8. Then let's say sample mean is 8. Sample mean is 8. Then definitely this the third value should be 9. third value should be 9. Why? Sample mean, that mean here 15, 90, 24. Divide by 3. No? Sample mean should be 8. To be a sample mean 8, the last value should be 9. How about these two values? These values are 7 and 8. But the sum of these values are 15. Sum of these values are 15. Then they have freedom to change. It may be 10 and 5. It may be 9 and 6. Free to vary. Okay. They are free to vary for any value without changing sample mean. But the third value should be 9. Did you got the point? This we call increase of freedom. If the sample size is 10, then the 9 values can take any value, but the last value can't change. If you want to keep your sample mean same value. You got the point?
Yes, sir.
Okay, then this is the end of discussion related to confidence interval estimation for mean. Then the similar kind of things we can do for proportion. Then the next week we will discuss it. I hope you have enjoyed the session because we start with the 34 students, still we have 30. That means it shows that you may interest about this session. Any feedback about today's session? Then I'm going to wind up the session.
So excuse me.
Yes.
So this is regarding the assignment.
Uh-huh.
So the assignment, the last question, question 8 asked us to write a reporting that's for 5 pages.
Mhm.
Should it be 5 pages, or if it goes beyond 5, something like 10, 15?
Yes, actually, this is my objective is not to get a research paper. Okay, just I want to see whether you can analyze the data. Then, yes, including table and chart. If you have 5 pages enough, but if you want to develop this into research paper, or if the 15 pages, all the 15 information in all the 15 pages are necessary information, it's okay. But let's say you can write 20 pages, but sometimes some may be not relevant. If you put not relevant one, then it's a maybe negative. I'm going to get negative marks, but it will not increase your marks. Okay. If all the 15 pages are relevant information, definitely you can get the higher marks. If it is not relevant, then you may get low marks.
Oh, okay, sir. Thank you, sir.
Okay. Okay, then please upload your data set also into LMS, because I received the mail, because I think at the day of submission, the portal is not available. Then please, now also I think you can upload. Please upload your data set and everything into LMS. Okay. Okay, then we will meet next week. Any other comments? Shall I wind up?